Good evening, students. Okay, so I'll start my class from 35. Okay, 4:35. 4:35. Okay, yeah. Students, good evening. So, because of some software related problems, so it got delayed. Okay, sorry for that. Students, are you able to hear me? Okay, so turn on your cameras first. Students, 1 minute. So, now today we'll discuss about a law of reciprocal proportion. 1 minute. Yes, students. So, it is a law of reciprocal proportion. Okay, law of reciprocal proportion. See, students, here let me consider three molecules. So till now what we have studied, okay, till now what we have studied, law of mass, okay, law of conservation of mass, and second one a definite proportion, and third one is multiple proportion, and fourth one is Gay-Lussac law, and fifth one is nothing but, what is that, Avogadro law. Okay, it's a special case of Gay-Lussac law. Now we'll study the law of reciprocal proportions. So till now we have applied our knowledge for two components. Okay, say for example in a definite proportion, so we took a carbon as well as oxygen, and we have studied how, what type of percentage or else what type of combining ratio is there in carbon as well as oxygen in case of carbon monoxide as well as in case of carbon dioxide. Students, now we'll take three components. Law of reciprocal. To explain the law of reciprocal proportion, I have to take three components. Okay, I have to consider three components. So exact definition, if you want, you refer your textbook. But the meaning is like this, students. So you take element A as well as element B. Okay, so element A as well as element B. So these two elements A as well as B combines with the common element, that is C. Students, so till now what we did, so we took two elements and the mass of those two elements was fixed. Okay, for example in previous cases, see, we took a carbon monoxide as well as we took carbon dioxide, so where the mass of at least one element must be same. Okay, so to take the ratio, the mass of at least two elements must be same, otherwise you can't take a ratio, comparison becomes difficult. So now here, take two elements, sorry, total three elements. Out of that, two elements may be different and they combine with the C. So what is the meaning of this? That is nothing but A combines with C as well as B combines with the C. Okay, now students, you take the ratio of A is to C, or else you take the ratio of A is to B is to C. Okay, so now you will get some answer. Okay, some answer you will get.
Ma'am,
So yeah.
ma'am, ratio by mass.
Okay, okay, wait. Okay, so mass, anything, okay, mass or else volume. So depending upon the physical state, okay, physical state. So for us, it is easy to express in terms of mass. So we'll consider it in terms of grams. Okay, so I'll give a particular example. At that time, we'll come to know. So you can take a sodium instead of A, you can write sodium. So their mass is 23. So in that way, I'm going to explain. So it is true even for liquid state also. students, but you have to consider a volume or else ml. So now take some answer, okay, take the ratio, you will get some answer. Take the ratio, you will get some answer. Okay, so now this answer, as well as you take the ratio of these two. So now what happens, I will explain it with the example, otherwise you are not able to understand in this. Okay, it's difficult. So you take a ratio, two sets of ratio are to be taken. Okay, so those two ratios may be same. Okay, may be same, ratio may be same, or else it may be different, students. It may be same or else it may be different. If it is different, then it is a multiple of the first ratio. Is this clear? If it is a different, then it is a multiple of the first ratio. So that is the meaning of this law. I'll repeat. Here you have to consider three elements. Okay, so fix one element, and this combines with this, or else this combines with this. Okay, so take these two situations and explain this. So at the end means finally you are going to calculate the ratio. So in that ratio, what happens actually? In that ratio, it may be, so you have to take a two sets of ratio. It may be same or else it may be different. If it is same, okay, don't worry. If it is a different, then just check if it is, it must be a whole number. Okay, or else a multiple of the first one, or else what is the total meaning of this law of reciprocal proportion? You will get the two ratios. Those two ratios must be whole number, simple whole number. So you can't write any fraction. So that is the meaning, students. To explain this law of reciprocal proportion, I will explain, I'll give this example. One minute. So students, you take a carbon, example for reciprocal proportion, carbon you write, and you write hydrogen, and you write oxygen. Okay, so write this triangle. So what compound you can prepare it from this? So carbon as well as hydrogen, methane you can prepare, as well as carbon as well as oxygen is there, you can prepare carbon dioxide, and here hydrogen is there, oxygen is there, you can prepare water. Okay, so now so I have to consider two set, total three compounds are there here, three compounds are there. I have to consider at least two compounds where mass of at least one atom must be fixed. So which compound I can take here?
methane and carbon dioxide.
Methane as well as carbon dioxide. Students, I will take a methane, that is CH4, as well as CO2. So now we apply stoichiometry for this. So what is the mass of the carbon? So it is a 12 gram, right? 12 gram combines with the 4 gram of hydrogen over. Then so here you will get a 2 gram, sorry, 12 gram. It combines with the 32 gram of this. So what is the ratio of this, student?
3:1.
3 is to 1. Where you have to concentrate? What about this 12 gram? You leave this because it is fixed. Okay, so 4 is to 4 gram is to 32 means what is the simple ratio?
1:8.
1 is to
8.
1 is to 8. Okay, 1 is to 8. Is it clear, students? Is there any confusion in this? So students, if I take this much, what is this? Which law is this?
Law of reciprocal proportion.
No.
Multiple.
A law of multiple proportion. If I explain methane as well as CO2 in this way, it is a law of multiple proportion. Law of multiple proportion says that, so you have to take two carbon atoms, or else any two atoms, its mass must be fixed. Okay, its mass must be fixed, and you take another, it combines with another. So what happens actually, so those two elements, they combine with each other in a simple whole number ratio. Okay, over. So now how to apply it in terms of reciprocal? So I have taken the CH4. Okay, CO2 is also over. Then one more compound is left here, so that is nothing but water, so H2O. So what is the combining ratio? So you apply your stoichiometry knowledge. So here it is 2 gram. correct? 2 gram combines with the oxygen. Oxygen how much? 16 gram, correct? Students, you take the simple number ratio, so whole number ratio, or else you take the ratio of this. How much?
1:8.
1 is to 8. And now you just compare the ratio of that as well as this. So it is same, correct? It is same. Is this clear? So this is nothing but a law of reciprocal proportion. So that means you consider, 1 minute, I'll repeat. See students, consider at least three element or else atom. So using these three, prepare three compounds. Okay. So now in this, consider two compounds and then apply law of multiple proportion. You will get some answer here. Apply law of multiple proportion, you will get some answer. Then the third reagent will be there, right? The third compound will be there, right? So in that third compound, take the if you take that third compound and then take the ratio. That ratio as well as this ratio is same. Okay, in this case it is same, or else if it is a different, then it will be a multiple of this number. Is this clear? So we'll solve another problem. Say students, if you read that the problem which is given in your book, it is not clear there, correct? So you can't calculate, means it is possible, but fractions of weights are given, so it is not that much clear. You can give this example. Okay, so it is actually clear. I think it is clear. Law of reciprocal. Okay, three element you take, prepare three compounds. Out of those three compounds, take two and then apply law of multiple proportion. Okay, then take the another compound and compare the percentage. Okay, is this clear? Okay, so I will give you another example. NaClH. Write all possible products. Student, did you take your school? Tell me, students, did you check your Schoology? Can you hear me?
Yes, ma'am.
Yeah, did you check, students? Checking?
It is breaking. Your voice is breaking.
Okay. Can you hear me?
Yes, ma'am.
Yes, ma'am.
Now, what about audio? Is it breaking or what?
No,
No,
ma'am,
it's
it's
talking.
clear.
Okay. Students, what I was asking, did you check the Schoology?
Physics test is there. That is
Mm.
It is not a physics related to physics test. So some notice came in the in the end of August.
Ma'am,
Do you
regarding which thing?
regarding videos, cameras? Huh? So that Schoology updates will be given to you students. Suppose if I don't give Schoology updates related to exam, suppose if I and so okay, I'll do the same thing. Next week exam is there, okay? Chemistry exam. I will never give a update in that Schoology, okay? Let me check. See, for that you don't know. Okay, you think that we have to update. Okay, so if I update something related to video, then no one is bothered about that. Correct. See, Chirag, still whether you are checking Schoology. So let me check. So next week a chemistry exam is there, but I don't want to give Schoology updates. Okay, let me check. Even this one is there. Okay, quiz is also there. So it's actually a surprise. A day will be at means particular day. So next week 4 day classes are there, right? Oh, so okay, not 4 day, only 2 days. 2 days chemistry class. So that means you have classes all the day. Out of those, two classes are chemistry. So it is very difficult to give announcement to you students, right? Immediate you will call. So whether class is there, only 2 day or else 4 day like that. So it is very difficult. Okay, students. Out of those 2 days, one is a surprise chemistry quiz and one more is a surprise test. Okay. So this is the announcement. Schoology update will not be given. Okay, students. So now take sodium, chlorine, hydrogen. Yeah, write all possible products. So here you just write sodium as well as chlorine. What product you can prepare? What compound you can prepare?
Sodium chloride.
Okay, so what about this? Sodium hydrogen is there. Sodium and hydrogen.
Sodium hydride.
Sodium hydride.
Dried.
Okay, hydride. Okay, so now HCl. So now apply the same law. Students, so what I have to do? First I have to apply. What is that rule?
Multiple proportion.
So multiple proportion. To apply multiple proportion, I have to consider two compounds, right? So which one is easy?
Ma'am, any two compounds you can take.
Any two compound. Any two
Ma'am,
compound.
NaH and NaCl.
Okay, so Anika, now why you have to consider yeah, you can consider any two compounds, but what happens? One answer came related to NaH as well as NaCl students. Okay, don't write anything now. What is the mass of this Na?
23.
23. 23 is to
1.
1.
1. What about this?
23 is
23 is to 35.5.
35.5.
Okay, so this is a fixed, right? You take the ratio.
1 is to 35.5.
Is it allowed?
We can round off now, ma'am. 35.5 will make it 36.
36. Okay, so rounding off is actually
Ma'am, multiply 2 on the both side.
But
that
will
much.
that be simple whole number?
Yeah,
Yeah,
that is
it's
2
actually
is to
simple.
70.
2
Take
is to
NaCl and HCl.
yes. So if it creates a confusion, okay, so that means I'll get a fraction here, but my law says that you should not write a fraction here. You have to write a simple whole number. Correct? So instead of you take those two, instead of those two, you take this one.
Ma'am, for this section, how will objective questions come?
Objective. Okay, so that is also surprise for you. Okay, so you just check this Cl. Okay, so you write you one surprise. First surprise will come in quiz. One more surprise in DPP. One more surprise in test. Okay, that time you just check. Okay, so here what is the mass of this sodium?
23.
23. Okay, so what is the mass of this one? Hydrogen 1. Chlorine 35.5. So that I can fix this one. So take the simplest ratio.
23 is to 1.
23 is to 1. Okay. This is the simplest. I can't write. I can't simplify this once again. Yes, so next one more thing is remaining. What is that?
What?
NaH.
Yes.
I am not able to send message to you.
Is it? If someone is there inside, no. Correct. No one is there. Yes, teacher is there here. But 1 minute.
It's showing teacher is not in this meeting.
But the teacher is there in the class, right? Yeah. Some students did the same thing in the last class. That teacher is not, so it's okay. Zoom. 1 minute. Yes. Now we just try. No, you log out and come.
Ma'am, once if you'll message in the chat, ma'am, then we can message you.
No, mom, I'm able to message you.
Yeah. What is that, Mitullah?
Ma'am, I tried.
Now we just try.
Yes, ma'am, now we can.
Okay.
Now we can.
No, Anika, I can't. I can't help in this case. Okay. Because you are irregular to Schoology, I know that. So therefore, this surprise test will be given. Yes, Shashank, and I got. Okay. Now you take the this one, a percentage or else a ratio. What's the
23
ratio?
is to 1.
23 is to 1. It is the same? Correct, right? It is same. I'll give one more means of different kind. So we have solved the two sides here with the same ratio. It shows the same ratio. Okay, so let me give one more thing. Copper, sulfur, oxygen. What happened, Muralidhara? CuS, CuO, SO3. You just try this. Tell me the ratio. Is
What
the
is the
same?
mass of copper, ma'am?
Copper 63.5.
Just take it constant.
Ah, yes. Whether it's a homework for me or else for you. It's a work for you. Okay, do it. Tell me the ratio. Very clever students. See, students, turn on your cameras. Mass of copper is 60. Okay, I'll write here. Copper is nothing but 63.5. Oxygen is 16. Sulfur is equal to 32 gram.
The ratio is not the same, ma'am.
Yes, the ratio is not same. Yes, sir. Muralidhar, tell me.
But ma'am, it is also possible to form SO2, right?
Yes, O2 also, okay.
Yeah, that will obey the law of reciprocal proportion.
This also obey. Okay,
Oh,
law
okay.
of reciprocal is nothing but it does not say that that ratio must be same. May be same or else may not be. In that case, it is may not be. In that case, it is a whole number ratio or else a multiple of the first one, first ratio. Is this clear?
Yes.
Yes. Yeah. Now tell me how to calculate. Muralidhar, how to calculate the ratio here? Shall I take CuO as well as CuS?
Yes, ma'am. You can take.
Okay, so what is the mass of this copper?
We need not worry about that. See you once.
Okay, but I have to write the mass here.
63.
So yeah, your answer is good. So I'll do the same. I see you are giving answer like this. So if you call, I will give the answer like that only. Okay, you just check. Okay, or else you will ask no for the exam. So you don't worry about the portion or else exam date. Come and write. At 4:30 it will be announced in the class. Yes, 63.5.
5.
So is to
32.
32. Okay. So then what about this copper as well as oxygen?
63.5 is to 16.
How much it is? 16. Okay. So this is fixed. Now you take the ratio of this 32 is to 16. So what is the answer?
1 is 2 is to 1.
2 is to 1. Yes. So next you take one more thing that is nothing but sulfur trioxide. So it is 32 is to 16. It is actually 2 is to 1. Okay. So now you take SO3. Here it's actually
32 is to 48.
48. So simplify this.
2 is to 3.
2 is to.
3.
Any objection for this answer? Is there any objection for this answer?
No,
No?
ma'am.
Okay. So let me check what happens in this case. CuS, CuO. So the ratio will remain same. So that is 2 is to 1. Okay. So now you take SO2. What's the answer? Yes, Muralidhar, continue.
32 is to 32.
32 is to 32. So what's your answer?
1 is to 1.
But at that time, what you told?
SO2 works.
So it is, see, it's not working right now. Correct.
Yeah.
So what is your conclusion?
We have disproved the law of reciprocal.
So impossible, but you got a simple whole number ratio. Okay, it is a multiple. So 1 is to 1 as well as 2 is to 1 is a multiple, right? So therefore it obey reciprocal law. Okay, law of reciprocal proportion. Here also same thing. Okay, so it obeys the law of reciprocal proportion. Is it clear? Yes. So that ratio may be same or else may not be. Okay, may not be. In that case, what you have to consider, whether it must be a whole number or else multiple. Okay, so this is about the, okay, total 6 laws we have studied. So this completes this chapter. So students, one target is there, task is there for you. You have to solve all textbook problems as well as workbook problems. Okay, so after that, so once again there will be a surprise in next week. Okay, but you have to solve and come.
I had a doubt in textbook problem.
Yeah, that will not be discussed now. Okay, so we'll discuss everything at a stretch, that is problem as well as the textbook problems. Is it clear? Okay, that is a homework for you. You have a free time Sunday afternoon. Yes, there you can solve. Students, now let me start a new lesson, metallurgy. Students, so what do you mean by metallurgy? Metallurgy means it is related to the extraction of metal. Correct? Metallurgy is related to the extraction of metal. So now here different techniques are there, students. Okay. So here first let me explain some important terms. Okay. For exact definition you refer your textbook. See, usually metallurgy means you have to extract metal after mining. Okay, mining means after mining you will get a mineral or else chemical compound or else chemical substance. So from that chemical substance, you have to extract metal. Okay, from that chemical substance, you have to extract metal. So now what happens in the extraction? You need to remember some important terms. Okay, so I can say here metallurgy is nothing but extraction of metal. So, but from which part I have to consider? I can't extract metal from the chemical substance, that is from the mineral. It is not easy. So, extraction of metal is done only from ore. What is the difference between mineral as well as ore? So, we'll study everything in detail. So, the first term which is used in this case is nothing but mineral. So, students, what do you mean by mineral? Okay, mineral is nothing but a naturally occurring, so write it full. Okay, naturally occurring chemical substances. Okay, chemical substance, naturally occurring chemical substance which is obtained after mining. Okay, which is obtained after mining. Okay, so did you get the point, students? You do mining, you will get some chemical compound. That chemical compound is nothing but a mineral. Is it clear? Is this clear? This concept is clear, right? Yes, students. Now, in this mineral, you have metal as well as large amount of impurity will be there. So I have written I as a very big I because maximum amount of impurities will be there. Is it clear? You have to remove those big I, in the sense it is a maximum amount of impurity which is there in that. So you have to remove that. Then only you can extract the corresponding metal. Okay. But students, extraction of metal is actually impossible from mineral. So what you have to do? What you mean by extraction? So metallurgy is nothing but extraction of metal. Correct? From where? See, already mining is over, right? So you have some chemical compound. Okay, sit and pick the metals. Sit and pick the metals. Is it easy? Okay, if it is very easy, then this much of everyone will pick something. Means
Then
gold.
this chapter would
Yeah.
not be there.
Would not be there. One thing, and then what about? Just imagine about a gold. Correct? So after mining, I can sit, okay, everyone will do mining of that gold and then sit and collect that gold. It is profit, right? Okay, so now what you have to do? It is not easy to extraction of metal is not easy from mineral. So what you have to do? So you have to extract metal. So while doing extraction, you have to concentrate on two things. Okay, extraction must be economical one as well as convenient one. Is it clear? Convenient one. First point is convenient. Second point is economical. If you waste highest money on the extraction of a particular metal, okay, so one student or else one person may invest crores of money for the extraction of same metal, and one more person may invest less amount for the extraction of same metal. At that time, that is economical. The second person is there, right? That extraction, he is doing some extraction, right? That extraction method is economical one. So you have to obey that one, that extraction rule or else procedure, students. So let me study about ore. So the next point is nothing but ore. One is mineral. First one is mineral. Okay, so it is a naturally occurring chemical substance over. So the next one is ore. So in the some mineral you have metal as well as large impurity. Okay, maximum amount of impurity. Okay, the second one is ore. What do you mean by ore? So ore is a chemical substance. So once again, it is a chemical substance. So from this chemical substance, from this metal can be extracted. Metal can be extracted. First point, economically as well as conveniently. If you extract metal economically as well as conveniently, then that mineral is called ore. Okay, that mineral is called ore. Is it clear? Is it clear? So now let me give some example for this ore. So suppose if you consider aluminium, it has two ores. One is bauxite, okay, and one more is clay. Both bauxite as well as clay contains aluminium. Clay means what? Clay means what, students? Very difficult?
Is it the normal plate, sir?
Normal mud. Okay. Can you sit and it is economical one, right? Correct. So what you have to do, you have to extract aluminium. What is the concept? You have to extract corresponding metal economically. Okay, it is economical, but to pick aluminium, you need it is economical, but it is not a convenient method. Correct. So you may take a very means I think 1 minute, 1 minute. Students, 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 take a 2 minutes break. Take 2 minutes break. I'll come now. Okay. Yes. students? Yeah. Turn on your cameras first. Yes, students, coming to this ore part, okay, so their extraction of metal is done economically as well as conveniently, okay. So aluminum is there. In case of aluminum, two minerals are there, so that is actually bauxite as well as clay. So from clay, economically I can extract, but it is not a convenient method. So therefore, it is not a ore of aluminium. Clay is not a ore of aluminium. Even though it is economical, it is not a convenient method. So it is not a ore of aluminium. But what about bauxite? Bauxite is nothing but Al2O3. Okay, so from this I can extract aluminium conveniently as well as economically. So therefore, aluminium, for example, if you want to extract aluminium, then you have to consider this bauxite. So bauxite is the ore of the aluminium. What about bauxite as well as clay? Both are minerals of aluminium. Okay, both are minerals of aluminium, but bauxite is the ore of aluminium. So is it clear, students, what I mean by ore? Ore is the one from where you can extract metal conveniently as well as economically. Is it clear? Is this concept is clear? Okay. Both are minerals of aluminium, but bauxite is a ore is a ore of aluminium. Bauxite is a ore of aluminium. Okay, another example I want to give. So you take a iron. Okay, I want to extract iron. So if you do mining, then iron is available in different forms. Iron sulfides are there, sulfides. Okay, so then you will get iron oxides, iron sulfides, iron oxides, iron carbonates. So what about these three? These three are minerals of iron. Okay, all these three are minerals of iron. Is it clear? But what I have to do? I have to extract metal. That is nothing but I have to extract iron. Okay, so you have iron oxide, iron sulfide, as well as iron carbonate. But here in this case, iron, it is found that extraction of iron is economical one as well as convenient from iron oxides. Okay, it is not easy to extract iron from iron sulfides. Okay, as well as iron carbonates. Easy in the sense there may be a economical problem or else there may be a convenient problem. So these two problems may be there in that. Okay, if any one is not holds good, then you can't consider that as a ore. Okay, is it clear? So now in this case, iron oxide is considered as a ore of iron. So it may be, students, it may be hematite. Fe2O3 is nothing but a hematite. Okay, or else one more thing, that is Fe3O4, that is nothing but magnetite. Hematite or magnetite. Is this clear, students? Mineral concept as well as ore concept. Is this clear? Yes. Now one more statement you have to give. All ores are, whether it is a mineral,
Yes.
all ores are minerals. Okay. But all minerals are not ores. Is it clear? See, this is actually iron. So this is a mineral, this is a mineral, this is mineral, but you can extract metal conveniently as well as economically from iron oxide. So this is a ore. Students, did you write everything in this? Whatever written here? Okay, yes. Now let me write one more thing, that is, you just write all ores are all ores are minerals, all ores are minerals, but all minerals are not ores, all minerals are not ores. Remember this. So students, I have studied three things now, two things now. One is mineral and one more is ore. Students, I have already mentioned in mineral you have metal and then large amount of impurity. Okay. So, but in the extraction of metal, it is not okay. One more special term is there for that impurity. It is called gangue. Gangue particle. Gangue means what? It is a impurity present in the extraction. Impurity present in that particular chemical substance. Or else, or chemical substance is actually mineral, or else I want to extract metal from ore, so you can also write it as ore. So what do you mean by gangue, students? Gangue is nothing but impurity, remember that. Is it clear? Okay, so the next one is metallurgy. After studying all these three things, okay, what you can define, how can you define this, how to define this metallurgy? Okay, how to define this metallurgy term? So metallurgy is nothing but extraction of metal from ore. Extraction of metal from ore is called metallurgy. Okay, extraction of metal from ore is called metallurgy. One minute. Yes, ma'am. Yes, students. So now sorry for the disturbance. Okay, I have to deal multiple work here. Okay, so I'll complete this one. Okay, so now these are all the basic terms. Okay, basic terms. So now the work is nothing but the extraction of metal, how to extract these metals. Okay, so now students, for the extraction of metal, first what I have to do, I have to do mining. Correct? So if you study, see, what is this? This is extraction of metal. Extraction of metal in the sense, so first you have to check what type of mineral, or else, so you will do, okay, so you will do mining. After mining, you have to check, so metal, whether it is there in the free state or else in the combined state. So usually free state, or else it is also called a native state, or else a native ore. So free state or else native ore. So usually Usually no need to apply metallurgical process for this, but you can also apply. So you can also apply, but it is not compulsory. So if it is there in the combined state, if ore, so after the extraction, you need to extract, after the extraction in the sense after mining, you need to extract metal, you need to extract metal economically as well as more conveniently from ore. Okay, so if you have a combined state, means if metal is in contact with something else, at that time you have to apply all metallurgical process for that. So metallurgical process is useful for the combined state, or else combined or else ore which is there in the combined form. Okay, so now students, let me list all important metallurgical process. So just write metallurgical process. So next heading is a metallurgical process. So there are four important metallurgical process. So first one is nothing but, so students, the first thing is nothing but mining. Okay, after mining, what you have to do, so you have to crush it. Okay, so this is called enrichment of ore. Okay, so this in your book it is there as enrichment of ore. Enrichment of ore means you have to remove maximum amount of impurity from that, and then you have to increase the concentration of metal, so that extraction of metal is easy. So that is the meaning. Okay, so now coming to the metallurgical process, the first one is nothing but crushing, or else it is also called grinding. Okay, crushing or else grinding of ore. So and crush it, crush. Okay, 1 minute. Crush this ore and prepare a powder of ore. I'll write like this: crushing of ore. Okay, and prepare a powder, prepare a powder, powder of ore, prepare a powder of ore. Over, this is the first main metallurgical process which is you have to follow with. See, this main metallurgical process is to be followed for each and every metal extraction. Okay, so students, after that, the second main metallurgical process is nothing but concentration of ore. Second main metallurgical process is nothing but concentration of ore. So what do you mean by, what is the meaning of concentration? What's the meaning of concentration? What may be the meaning of concentration, students? So what you have to do? You have to extract a metal, right? Concentration of ore in the sense you have to remove, okay, maximum amount of impurity, removal of impurity. Okay, concentration of ore in the sense it is a removal of impurity. Okay, meaning is nothing but removal of impurity. Students, based on the nature of the impurity present in the ore, you can select different steps or else methods to remove the impurity. In the concentration of ore means in the this is a second main metallurgical process. In this second main metallurgical process, you can apply different methods to remove maximum amount of impurity. Remember, concentration of ore in the sense you are going to remove maximum amount of impurity. So that is the meaning. So depending upon the, I will explain it in detail, each and every process. Depending upon the nature of the impurity as well as the density of the impurity, you can say like that also. Okay, this concentration process can be done in different ways. One is a hydraulic washing, or else it is also called a leviation process, or else it is also called gravity separation. Okay, it is also called gravity separation. I will explain each and everything in detail later. Okay, so second process, students, I can use a magnetic separation technique. Magnetic separation. third process is nothing but a froth flotation process. I'll write little shortcuts here. So I'll repeat. The first process is nothing but hydraulic washing, or else it is also called a leviation process, or else it is also called gravity separation. Gravity separation. The second process is nothing but a magnetic separation. And third one is nothing but a froth flotation process. And in higher class, you will study leaching process. That is the fourth, another type of a process, that is a leaching process. And one more, the simplest method to remove the impurity is nothing but a simple hand picking. Okay, after extraction, if a very big, okay, so big in the sense, if a plastic is there, then what you can do, so simple hand picking. So that is also one of the method to remove impurity, correct? That is also one of the common method, comes under this concentration of metals, okay, or else concentration of force. Is it clear? Total 5 steps are there, but in your book you have to study only these 3. Okay, so if you want, you can also write. It's one more thing is there, that is a leaching process, and the last one is a simple hand picking method. Simple hand picking. Is this clear, students? Is there any confusion in the metallurgical process? Study this chapter properly. Over. Shall I rub? Till now, I have explained 2 main metallurgical process, not completely, but you know the side heading, only that much. So what is that? First one, after mining, you have to crush it, prepare a powder, and then from that powder, you have to remove maximum amount of impurity. So that process is called concentration. Only that much is known to you now. Okay, so these are all different techniques that we'll study it later. So students, the third main metallurgical process is nothing but isolation of metal. Third main metallurgical process is nothing but isolation of metal. Here 2 steps are there. 2 steps are there. The first one is nothing but conversion of concentrated, okay, concentrated ore into corresponding oxides. Okay, the third main metallurgical process is nothing but isolation of metal. So this isolation can be done in 2 ways. Okay, in that the first thing is nothing but conversion of concentrated ore into oxides. Students, that is the second one, second step. You just read that second step. What is that? Concentration of ore, correct? Now after second step you will get some product, right? That is concentrated. What you mean by concentration of ore? Removal of impurity, correct? You remove maximum amount of impurity, you will get something now. So what you have to do? You have to extract metal from that. But extraction of metal is must be convenient as well as economical one. Okay, so most of the time extraction of metal from corresponding metal oxide is convenient one. Remember this always. Why? Because you heat it, oxygen can be removed. Okay, when you heat the substance, oxygen is released. Now the compound is rich in metal. Okay, so that is the easiest method. So here once again different techniques are there. You can convert that concentrated ore into corresponding oxides by calcination process as well as by a roasting process. I will explain all this in detail. Calcination process as well as roasting process. Now what you have to do, the second step, reduction process. Reduction means what you have to do, this converted oxide will be there, right? So oxides, for this add proper add, so for, so you write like this shortcut, okay, oxides plus select proper reducing agent, okay, a reducing agent, it gives rise to the corresponding metal. So this process is the right addition of reducing agent. You are adding reducing agent to this particular reaction. So this process is called a reduction. Okay, so this is the third main metallurgical process, students. Third main metallurgical process is nothing but isolation of metal. Isolation of metal can be done in two ways. The thing which is there in the second step, so that is a maximum amount of impurities are removed. Okay, so what you have to do, you heat it and convert it one into corresponding oxides. For that oxide, you add reducing agent and you convert that one into corresponding oil. So from there you can extract a pure metal. Okay, pure metal. Yes, students. And now what about the impurity content? See, you are having metal here, but it contains small amount of impurity. Correct? So in the beginning, in the first, after mining, metal contains a large amount of impurity. Now at the end of this third step, this metal is in contact with a small amount of impurity. But you have to remove that small amount of impurity. Okay, you have to remove this impurity. If I add small amount of impurity along with your gold, then whether you will purchase? No. Correct? What you have to do? You have to refine it. Therefore, the fourth rule, or else the fourth fourth main metallurgical process is nothing but a purification, or else it is also called a refining or purification. So therefore, you just read the main side heading. See, like this type of points are there. Just read that, just glance it. So in the metallurgical process, students, I'll glance each and everything now. Just concentrate here. Turn on your videos. Okay, so just concentrate on the video part here. So first you have to do mining, correct? After mining you will get some chemical substance. That chemical substance is a mineral. Okay, so for example, if I want to extract some metal M, then it may have 2 or 3 minerals. At that time it is a confusing one. So what I have to do, I have to study the nature of all these 3 minerals, or else 2 minerals. Now decide one, means you take any one from that is actually nothing but ore. Correct? So from that extraction of metal is convenient as well as economical one. So this is up to ore. So clarification. So now mineral is known to you, ore is known to you. Okay. So now students, after mining, you'll get a mineral. Okay, identify the ore from that. Now what you have to do? You take that ore, grind it. Okay, crush it, prepare a powder. Okay, prepare a powder. Now this is the first main metallurgical process. What is your first main metallurgical process? Crushing as well as grinding. Prepare a powdered ore. Is it clear, students? Okay, so first process is over. What about the second process? What is your task? You have to extract the pure metal from that. But along with that metal, in the powdered ore, you have maximum amount of impurity. So what you have to do, students, now? You have to remove that impurity. Removal of impurity is called concentration of ore. Why? Because you remove impurity. So now this substance is rich in metal. That is the meaning. Is it clear? Is this clear? So now what is the second main process? Process is nothing but concentration of ore. How to remove that impurity? So you select different 5 steps are given. So if plastic is there with that, then sit and pick the plastic. So that is called simple hand picking method. Okay, and depending upon the nature of the, or else density of the impurity, you can select a different process. It may be leaching, or else it may be gravity separation, or else it may be anything. Okay, hydraulic washing, froth flotation process, etc. Okay, over. So now at the end of the second process, maximum amount of impurities are removed. Is it clear? Okay. So now in this third step, in the third main metallurgical process, what I have to do? I have to extract metal. I have to extract metal. What is there now? I have a concentrated metal, because of this is the second step, second main metallurgical process. Now extraction of, you have already given a definition for me, that is nothing but extraction of metal must be convenient as well as economical one. Now I have to search different path in such a way that extraction must be convenient as well as economical to me. Correct? So if you study those procedures, most of the time, if you consider metal oxides, extraction of metal from metal oxide is easy. Is it clear? So what is your work? You convert that metal to corresponding oxides. So that means what is there with you now? Concentrated ore is there, concentrated metal is there. Okay, you convert that one into corresponding oxide form. After that you go for extraction, metal extraction. So how to convert that concentrated ore into corresponding oxides? So students, turn on your cameras first. Okay, so now how to convert? So you have to convert that one through calcination process as well as roasting process. So we'll study it later. So what is that calcination, roasting, everything we'll study it later. Now at the end of this third main first process, okay, third went yeah third main, okay, so third main first process. After this process you will have oxides, okay, oxides of metal. What is the third main second step? You just glance your book. Okay, so third main second step is nothing but add a reducing agent to that. Okay, to oxide, metal oxide is there with me, add reducing agent, so that will undergo reduction process of, so from there I can extract the metal. So now in this metal, very small amount of impurity will be there. Okay, maximum number of amount of metal, small amount of impurity will be there. I have to remove this impurity. Okay, so correct. So what I have to do? I have to go for the fourth main metallurgical process. So that is nothing but refining or else a purification process. Is this clear? Four metallurgical process is clear, right? All are clear, right? Okay. So let me do mining first. Okay. So I did mining. Okay. After that I got some chemical compound. So that is nothing but a mineral now. Mineral is there with me. Okay, so imagine I have 5 minerals of a particular element A. So now what I have to do? What is my next step? Yes, students, tell me.
Find the ore.
Okay, identify the ore. Out of 5, okay, first one, okay, so I'll write like this. The first one, second one, third one, as well as fourth one, as well as fifth one. So identify the ore. Imagine this third one is a ore of this metal A. Okay, you can select anything. Don't ask why not second, why not one.
No,
Huh?
is economic or convenient.
Yeah. Or see why I have selected third one. According to me, that is a convenient as well as economical. But need not to you can select even first one, or else even second one, even fourth one, even third one, as well as fifth one, because we don't know any experiment. We don't have any experimental data here. Okay, if I have experimental, see, you can't do the same thing for aluminium. Correct? It is already done by someone. But I don't know what is this A. Just for an example, I took 5 minerals. Okay, first one, second one, third one, fourth one, fifth one I wrote. So you take what you want, students. Is it okay? Shall I take third one? Okay, no objection for this. If you have objection, then you select the proper one, what you want, that you select. Okay. So over. Then what I have to do, students, now?
Crushing and grinding
Okay.
and making
Take
it to
that.
powder.
Yes. Third one you take. Crush it. Okay. Grind this. Prepare a powder of this one. Third ore. Okay. Not a third ore. It is a ore. Ore of this mineral A. It's not a third ore, students. It is just a ore. Ore of this mineral A. Sorry, metal A. So next what I have to do. So this is the first main metallurgical process. It's over. Okay. Then what I have to do? Go for the second one.
Concentration of ore.
Okay. Concentration of ore. Concentration of ore. Students, concentration of ore means what? I have to remove impurity from this. Correct? I have to remove impurity from this third ore. Okay, not a third ore. Okay, just ore. So here it is third one. Only that much. Okay. So now which method is to be selected? So till here any confusion? No? Okay. So now let me explain. So is there any confusion in the first main metallurgical process? No, right? Okay. So then let me explain this concentration of ore. Okay. Concentration of ore. That is nothing but a second main metallurgical process. Second main metallurgical process. So let me take simple hand picking method first. Simple hand picking. So what you have to do? So here in metallurgy, students, principle is important. Principle in the sense last spelling LE, not AL. Okay. So principle is important here. So what is the principle of this hand picking? So here the size of impurity is very, very big. Okay. If the size of impurity is very big and it is visible for our eyes, naked eyes, then only I can apply this technique. So that is nothing but simple hand picking method. Okay. So remove maximum amount of impurity. Over. There is no confusion in this. So go for the second one. So what was that? Hydraulic washing. Students, what is the name of the what you can understand from this name?
There is
Hydra means,
water.
yeah, water. What you have to do? Collect. You take one tank and then collect mineral or else. So what I have to collect? Ore or else mineral?
Ore.
Ore. Okay, transfer ore into that tank and add water. What happens now? What happens? What may be the principle? What may be the principle? Students, I'll write this heading first. So hydraulic washing, or else it is a ligation process, or else it is also called a gravity separation. Okay, gravity separation. Here the principle is like this. Okay, principle of this process. Here impurity is there, right? Impure, it is okay. So let me write only this much. So it is not a important, it is a impurity, but it is important too. Or else you write, if it is a confusing term, you can write it as a gang. Okay, it is better. Okay, gang is nothing but impurity. So impurity must be lighter and metal is there, right? It is heavy. Metal must be heavy. Then only you can use this, correct? So now you take one tank beaker, or it is not easy to do this extraction in beaker, students. So this is actually tanker. Sorry, it's not a tanker, it's tank. Okay. So now you take one, just for an example, this is your extraction chamber. Okay. So tank reversible. So it is called furnace. Okay. Furnace. So add water and add, you consider that crushed powdered ore, add water to this. Okay. So when to select this particular method? If you know the impurities which are present in this is lighter and it floats on the surface of this, okay, then you can easily remove that. But metal is heavier. Metal is heavier. If you know this thing, then only you can apply this technique, this process. Okay. Then you may ask how to know. Uh, who will tell this impurity is light?
Trial and error.
Trial and error, one thing, or else some scientist did already. So you have to refer that standard chart. Okay. Okay, so trial and error is okay, but if you have a gold thing, then if you do trial and error, you will lose your, yeah,
No,
then
ma, with
fill,
small
See the
amount.
densities and
yeah, density you can check. Okay, density is everything, it depends upon density here. Okay, metallurgy part. And mass is very important for us. Okay, metal mass is very important. So in the extraction, see, almost all metallic extraction I can get a standard chart. So select a proper, okay, see that chart and then select a proper method and then purify it. Okay, go for concentration process. So here students, here, did you get the meaning of this? See, take one chamber, reaction chamber. Ore is there here. Ore means metal will be there as well as a large amount of impurity will be there. So what is the condition of this impurity? Impurity or else a gang particle is lighter and metal is heavy. Okay. Add water to this. Add water to this. Okay, add water. Then what happens? So this impurity is there, right? That will float on the surface of this. So this is an impurity. Remove this. Remove this impurity. At that time, you can get something in this reaction chamber. That is, reaction chamber is rich in metal. Okay, reaction chamber is rich in metal. Is it clear, students? So what is this process? What is this process? No.
Hydraulic washing.
Yeah, that is okay. Why you have to do? Why? Okay, rich in rich in metal means overwrite metal extraction. Did I complete almost all attraction? Sorry, metallurgical process, extraction process? No. What I did now?
Removed impurity, some.
Only that much. Okay, I have removed impurity, only that much I did. But I have removed, okay, so use the term, I have removed maximum amount of impurity. Maximum amount of impurity, very big amount of impurity. Big size, you can also say like that. Okay, size is also big. Over. So now the metal which is there here is not a pure metal. It's not a pure metal. Okay. So now I want to discuss 5 different steps. Okay, not 5 completely. So only 4. 4 is enough for you. Okay. So now I want to discuss those 4 methods here under concentration of ore. So in all these process, I will remove impurity, only that much. Okay, so what is the first process? Simple hand picking, that is clear. And what is the second process? It is a hydraulic washing, or else it is also called levication process. It's a Greek one, Greek term, only that much. And what about the gravity separation? So there is a difference in the gravity, right? So if this one, that impurity part is there, right? It is lighter and metal part is denser. So automatically you can compare it with the gravity. So therefore the name gravity separation. Is it clear? Is this clear? Yes, students. So the next one is nothing but one minute. Second main metallurgical process, that is nothing but concentration of ore. But let me explain the third process here. So that is nothing but a magnetic separation. Before that, students, you can also write the example for the previous one. Levication process is there, right? You just write hematite is an best example for this. Hematite, Fe2O3. 1 minute. See, for levication process or else for hydraulic washing process, you can write hematite as an example. Is it clear? Clear? Yes. Now coming to the next process, that is third process, that is nothing but magnetic separation, or else it is also called electromagnetic separation. Both are same. Okay, magnetic separation, or else it is also called electromagnetic. So it is there. Okay, it's electromagnetic separation. electromagnetic separation. Okay, students, here principle is like this. Principle. See, either metal, okay, or else impurity, any one of these two, okay, must be magnetic. Must be magnetic. For example, this method is applicable for magnetite ore. Okay, magnetite. So in this case, iron is a magnetic one. Iron is correct, metal is a magnetic. Okay, so what is the principle of this? Either metal or else non-metals. See students, if metal is okay, so I will specify this as principle like this, or else I'll write this principle like this. If first situation is like this, if metal is magnetic, then the corresponding non-metal must be corresponding impurity must be non-metal. Okay, are you able to follow this process? No response. Are you able to follow? Yes, you study this chapter well because it's actually an economical one. After studying everything, so what is the last one we have to do money, correct? That is very important for us. So this chapter is very important so that you can earn. Yeah, students, turn on your cameras first. Yeah, so now impurities are there, right? So it must be non-magnetic. Okay, then the second process is there, second main process. Okay, second situation, metal may be non-magnetic and impurity may be magnetic. Impurity may be magnetic. Okay, different situations are there. Totally, this magnetic separation means it depends upon the magnetic property of the metal. Students, I'll bring one more slide. Wait. Yes, can you see this one now? Can you see this one, students? This diagram is visible, right? Yes, yes. Students, this is the technique which is used okay, so you just concentrate here. Magnetic separation method. Okay, this technique is used to do concentration. Okay, so principle is like this. It is based on the difference in the magnetic properties of the ore components. Ore components means what? It may be metal or else impurity. So what is the meaning? As I have already gave that metal, if it is a if metal is a magnet, then impurity is non-magnet. If metal is non-magnetic, impurity is magnetic one. Okay, students, its explanation is like this, means its procedure is like this. Students, you take two magnetic rollers. Okay, so belt is there here. So switch on this one, setting is there here. Okay, so now this process is there, right? So magnetic separation process is there, right? This is a second main metallurgical process. Before this second metallurgical process, you are going to do the first one. What is that? Crushing. You are preparing a powder. So what you have to do, students, you just concentrate on this diagram. So you add that powdered ore here. Okay, add that powdered ore here. So this powdered ore contains metal as well as impurity. Clear? Metal as well as impurity. Is it clear? Yes. Now what happens? Imagine metal is a magnetic and impurity is nothing but a non-magnetic. What happens now? So since these rollers, okay, rolling, okay, 1 minute, yeah. See, magnetic rollers are there, right? So these two are magnets. It acts as a magnet. Now, so you have added metallic ores, okay, finely grounded ore. So here actually metal is there, impurity is there. It will come here. Something will be collected here and something will be collected away from this. What is that? Which one will be collected nearer to the magnetic field, a magnetic roller actually, always?
Magnet.
Magnetic substance,
Metal.
okay, metal. In this situation I told you to imagine this one, okay, so metal is a magnetic, so that will be collected nearer to the belt. Okay, so since non-magnetic metals, non-magnetic particles, in this case it is impurity, so it will be collected away from the roller. Is it clear, students? Is this clear? Suppose 1 minute, you can also imagine like this. So what is there in that? Correct. You can also imagine that impurity is a magnetic. Okay, I'll do one thing. I'll give you two situation. Yes, students, in the first situation where metal will be collected.
Near to the roller.
Near to the,
Roller.
yes, nearer to the roller. So in the first situation, this is metal, right? Correct? And what about this? This is non-metal. This is the first situation. What happens in case of second one?
Far away from the roller.
Which one?
Metal.
Metal. So metal will be collected here, impurity will be collected here. Is it clear, students? What is the best example? Best example is nothing but magnetite. So that is Fe3O4. Okay, Fe3O4 is the best example in this case. Is it clear, students? What is the explanation of this? Take a metallic roller and connect it and then add powdered ore here. Okay, so if metal is magnet, then it will be collected nearer to the magnetic roller. If impurity is magnet, then that will be collected nearer to the roller. Is it clear? If metal is magnet, then that will be collected nearer to the magnetic roller. And then what about impurity? It will collected away from the roller. Is it clear? And vice versa. Is it clear? So this is what you did now, students. What you did now? Just to have removed impurity. Correct? So this is a concentration process. Is it clear? Okay. So this comes under main metallurgical process, that is second main metallurgical process, third method. Is it clear? Okay, no response, students. What is the time? Is it 6:30?
6:21.
That you know. See, exact timings. Okay. So if I say something, give response, no response. If I say something related to break or else a time, then you will get a proper answer. Students, then the fourth one is nothing but a froth flotation process. Froth means it is foam. Write this. This is a very, very important. So no need to write all these points. Okay. You have a textbook. Okay. Do self-study. Now, I will explain. See, students, this is a very important point. 1 mark you can say. You can expect 1 mark question from this. Froth flotation method can be used for the separation or else for the concentration of sulfide ore. Okay, it can be used for the concentration of sulfide ore, because here different techniques are there. Okay, different techniques are there. Little complicated process it is. Over. Okay, sulfide ores. Now, what is the principle of this? See, students, once again, ore. If you consider a ore particle means you have metal as well as impurity. You just write that. You just write metal as well as impurity. Students, principle is also once again it is important. Note down this principle also in this procedure or else in this method. So let me prepare. Let me take a ore particle in the sense metal is there as well as impurity is there. Metal is always wetted by oil. Okay, and impurity is always wetted by water. So this is the principle. Is this clear? So this is the principle. You have to do extraction based on this. Okay, is it clear?
What
Yeah.
is the meaning that metal wetted by oil? And
Yeah, wait. Wet means what? It is in contact. Okay. Is this clear? Only that much meaning here.
No, ma'am. How do they know which is metal and which is impurity? If they
Wait.
know, they can take it outside simply.
Okay. So simply in the sense, see students, froth flotation process is used for the extraction of metal from sulfide ore. Okay, sulfide or else sulfur is act as a impurity in this case. Okay, so sulfide ore in the sense metal is there as well as sulfur is there. Sulfur is a gang particle here. You have to remove this to extract this metal. Always remember, extraction of metal from corresponding metal sulfide is not easy. It is not economical one. Okay, so therefore a complicated process is to be followed. So always remember, extraction of metal from metal oxide is always easy. Okay, so you can remove that in terms of in the form of oxide or else in the form of oxygen, but here extraction of metal is not so easy, so therefore you have to do this circus. And wetted by means it is in contact. I will explain that procedure in detail now. Okay, so is it clear, students? Is there any confusion in the process? Sorry, in the principle? What you have to do? You have to take a ore particle. Ore particle means it contains metal as well as purity. Okay, so metal must be in contact, wetted in the sense it is must be in contact with the oil, only with the oil particle. And what about this impurity? Impurity must be in contact with the water. You should not exchange these two. It is not allowed. Okay, over, right? This much is clear, right? Is there any confusion? No. Now students, what you have to do? So this is the actual setup. Okay, this is actual setup, but in your textbook a little different structure is given. Different in the sense that is also correct. That is also correct. But peddlings means stirrers are not given there, so you may get confused. So therefore, it is better to draw this diagram. If you want, you draw. Okay, so just write a rough diagram. Rough diagram. Write it fast. So now it will show you the clear picture of that principle. Principle is nothing but metal is in contact with oil as well as impurity is in contact with water. Okay, write it fast, but yeah, Vivek, later at after 6:30, that is your exercise time. Okay, now you just draw this diagram. No quiz. Okay. Okay, so here one question is there. What if the density of impurity as well as metal, if it is same, then what happens? Okay, density of metal as well as impurity, if it is same, then you can convert that one into corresponding oxides. Go for reduction process. Okay, if it is very difficult to do isolation from this impurity, metal from impurity, so then go for, after first process, go for third process, convert that one into oxides and extract metal, go for refining. Okay, Shashanka V Pujari, is it clear? Yes. Yes, sir, Vivek, it is like a washing machine. Which one? So that is nothing but I think a hydraulic washing, correct? Hydraulic washing process, yes, correct. It's like a washing machine. How many ores can be there for one compound? So many you can write. You can write so many. Okay, so that depends upon the corresponding, yeah, it depends on Vivek. Yes, it depends upon the corresponding metal. Okay, yes. I did not get Shashank. What is this? Shashank Vipujari. Go to the crafting table. Why? Okay, here one question is there from Anika. So, what if extraction is neither economic as well as not convenient? Then simply you have to waste your time as well as money. It is a useless extraction. So, you can't extract any metal, or else you can't separate metal from impurity. In research, so we say this as a useless experiment. Is this clear, Anika? Okay, so but you can't say, without doing experiment, you can't say this is not economical one, or else this is not a convenient. Now we will teach and then we'll study because someone did it, correct? So so if you find something new nearer to your house, okay, so what you have to do first, you means if you find some metals, new metal, etc., so first you have to do experiments. Okay, so find whether it is a convenient or else economical method. After that you publish it. Okay, so same thing. Internet race, 1 minute. Is this Mithul? Because our classes are cancelled. Okay. Oh, okay. Now so many questions are there. Okay, so Sumedha, yes, good. Yes. Students, did you draw this one? Shall I explain? Okay. Now, students, what you have to do, you have to consider a ore particle. Okay, turn on your cameras first. Yeah. First, what you have to do, students, you have to, Sumed, where you enter? Consider ore particle. Mithula, yeah, consider ore particle. Ore particle in the sense it is a metal as well as impurity. Okay, metal as well as impurity. Prepare a suspension of this. Do you know anything about suspension? Suspension is not a surprise. Okay, so do you know anything about suspension? Any clue?
Heterogeneous mixture.
No. Heterogeneous. Yeah, mixture, correct. But it is, yeah, it is actually heterogeneous. But is there any particular meaning for this? See, students, you have to. Yes, Muralidhar, do you know
Which has
anything?
visible particles suspended in its mass.
Charge
Okay.
particles.
So, three types of solutions are there, students. A true solution, and
Suspension, collide.
yeah, collide. Okay,
In
and one
between
more
is
is
suspension.
in between is suspension.
We were taught like
Okay,
that, ma'am.
In between is colloid.
in between is collide.
Yeah,
Okay,
ma'am. But
so yes, tell me. But
no, ma'am. In the lesson, the way they say it is like that, ma'am. Solution, suspensions, and colloids. Last year's lesson, ma'am.
solution, suspensions, and collides.
Colloids.
Yeah, you do one thing. You shift, put arrow mark and shift the last one first, and then second one
Yes,
to the last one. Okay. Yes, that is good. So now, yeah, coming to this true solution, it is actually a solution. All are heterogeneous. All are heterogeneous, students. Okay. True solution is a heterogeneous, Anika. Colloidal solution is also heterogeneous. Suspension is also heterogeneous. Okay. So what is the time? Okay. So 33 it is. Okay, no problem. So let me explain this. True solution is there, colloidal solution is there, as well as suspension is there. So true solution is the one, see all three types of solutions are there. All three are heterogeneous systems. There is no doubt. Okay, heterogeneous. But
True solution is homogeneous, right?
true solution?
True solution is
Is
homogeneous.
homogeneous. Yeah.
Wait. Okay. So usually what I will say, solution is actually heterogeneous. Okay. But how, okay, you said that this is a homogeneous because you have studied. But when I asked this question, your face was like this. Okay. Leave that. So now, true solution is the one where you have to combine two things. So that is actually a mixture. Okay, here the particle size is very small. Okay, so in case of true solution, what you have to do, solution is what? Solvent. You take solvent and then dissolve solute in this, correct? So solute particles are there, right? Its size is very small. So when size is very small, you can easily dissolve that solute in this solution. Sorry, means in solvent, correct? So therefore it is a homogeneous. Is this clear? Yes. Now coming to this suspension is also a solution where the particle size is very big. Okay, particle size is very big, so it does not dissolve easily. Is this clear? Is this clear? Okay. What about this colloidal solution? Colloidal solution is the one, it is in between the true solution as well as suspension. It is not a very small, it is not a very big, it is in a moderate, medium. Is this clear? Is this clear? Okay. So now in this froth flotation process, I had to prepare a suspension of what? Suspension of ore particle. Ore particle means what? Ore particle is nothing but a metal as well as impurity. You prepare a suspension of ore. That means what I have to add now? Take a ore particle, add water. Add water. What happens now? What happens now? Is there any problem in that? So you just check the principal part here. What I said? Take ore particle, prepare a suspension using water. Now is it proper or else something is unusual in this case? Is it proper? Yes, Keaton Suman, why you turn on your camera first? Yeah. He said like this. If it is a proper, no, like this. Means which one is a proper answer here? That means Okay, so what I have to decide, time is up, right? So nothing will go inside. Yes, you just concentrate on the principle now. So if you add water, what happens? So the rule says that metal is metal. You have to add, say, metal must be in contact only with the oil, and impurity must be in contact with water. If you add water, what happens? Metal will be in contact with water. So at that time, the principle is so correct, right? What is the principle? Principle says that metal must be in contact with the in contact only with the oil. But if you prepare a suspension in water, then okay, this will not holds good. Is it clear? Is this clear? Why, etc. We'll study it in next class. Okay, I'll start it from froth flotation process. Remind me, okay? Yes, but be prepared for almost all types of surprise. Don't expect any updates in Schoology. Yes. Yes, students. Bye.